All right, guys, we're doing the final 2018 question number 4. Okay, we are asked to basically find kt plus 1. We're asked to find the law of motion of per capita capital. And we're also told the population grows at rate n and is n. So let's do it. We are told that the growth rate of n is equal to n. So in an OLG model, that means that the n at time t plus 1 is going to be equal to nt times 1 plus n. So let's just keep that in the back of our minds. And now you can just remember that in OLG models, kt plus 1 is equal to the labor force times the savings rate. But let's talk about where that comes from in case we forgot. The total economy, all the money in the economy, is spent in 3 ways. It's spent by old people consuming at time t. It's spent by young people consuming at time t. And it's spent, I'm doing air quotes, in savings. So this accounts for all of the money in the economy, all of the stuff. And where that stuff comes from, it comes from all of the output at time t, and we add to that all of the accumulated physical capital of the economy minus what's depreciated. So just like here, every period this grows by n, here every period this shrinks by delta. So we do 1 minus delta to say this is the stuff that didn't break down. And of this stuff, we think, where does new accumulated capital come from? It doesn't come from here, because that's consumed, nor from here. It's going to be a fraction of savings. So this is kt plus 1. And you can see it already kind of looks the same as this memorizable equation here. It's just that we have nyt is equal to lt. And there's no leisure in this economy. If there were leisure, this is where we would add it in the model. But since there isn't, we can just say that ny, the number of young people, is equal to the labor market, and that's the labor clearing condition. But in this model, we have a little bit of a wrinkle. Remember that with probability 1 minus p, we have an accident. And that means we are not working. Which means that with probability p, we are working. So in fact, p% of the total number of young people will be workers. So this is our new clearing condition. Rearranging, we find that nyt is equal to 1 over p times lt. So we plug that into here, and then plug that into here. So we're going to end up with is big K t plus 1 is equal to 1 over p times the labor of time t times savings. But we were not asked for big kt, we were asked for little kt. So to find that, we need to divide by L, and the subscripts need to match. So don't, you might be tempted to just be like LT, cancel, and then this is kt plus 1. That's wrong. It has to be divided by the labor force at time t plus 1. So it has to be lt plus 1, and here lt plus 1. Okay, so on the left we get k of t plus 1 is equal to, and so think about what to do with this. L is a group of people, and lt plus 1 is a group of people, and it's growing. It's a part of the population. And we don't have any reason to think that this part of the population grows at a different rate than other parts of the population. So what we could say, we could just replace this with n's, these n's with l's. We could say that lt plus 1 equals lt times 1 plus n. And dividing, we find that lt plus 1 divided by lt is equal to 1 plus n. But we don't want to know this, we want to know this. It's the other way around. So we need to flip the fraction. So we'll find it's 1 over 1 plus n. And that lets us simplify this. This is just going to be 1 over 1 plus n. So we find 1 over p times 1 plus n times s. And we know s. S is right here. It's already got a little star. So s star is this guy here. And we know the wage. The wage is going to be the equilibrium wage here. So let's plug all of that in so that we can draw a beautiful box around our kt plus 1. It will be equal to 1 over p times 1 plus n times the quantity. So s is 1 minus a times another quantity, p times another quantity, which is going to be 1 minus alpha a k alpha plus 1 minus p m, close brackets, close brackets. So there you go. We'll draw a beautiful box. Well, a box. I don't know if it's a beautiful box. And then the next video, we will talk about how to take this and solve for the steady state and try our best. But I think we're going to hit a bit of a snag as we do. I'll see you then.